A dot plot below represents a random sample of heights of 20 AP Stats students to the nearest inch. There it is, and there's summary statistics. Describe the distribution. All right, what shape would you give this? The distribution of AP Stats student height. So y'all gonna have to write fast. It's approximately symmetric. Knowing that, what measure of center should we use?
Mean.
And what measure of spread should we use? Yes. Be confident. Standard deviation. Yes, yes, yes. Not I.
Oh, it's standard deviation.
The mean is 67.45 inches. The standard deviation is 4.807 inches. Which really didn't have to go that far. And then glancing, would you think any of them are outliers? Maybe?
78.
Maybe 56 and 78? Yeah. 56 and 78 may be outliers. I don't need comparison words because I'm not comparing this to another distribution. But I do need context, which I have in my sentence. Outliers, center, spread, shape. All of it there. Okay? All right. Ms. Dobbs, that's me, is 65 inches tall. What percent of the heights are less than or equal to 65 inches? So here's 65. Less than or equal to, does that mean I include the 65?
Yes.
Yes. So count it. 1, 2, 3, 4, 5. Out of how many? Out of 20. What percent is that?
25.
25%. 25% of the heights are less than or equal to 65 inches. So then what's your height in inches? Do you know your height in inches?
5'11".
6 inches.
Oh, 6'4". Wait, how much is 6'4"?
5'11" is not 6'4".
I'm like 6'4".
I'm 66.
It's going to take 20 minutes. Okay, if you're 5 foot something, take 60. 60 and add the inches. If you're 6 foot something, take 72 and add the extra inches. 65?
No.
65? Yeah, that's the same as me, right? Okay. All right, anybody? Who's 6'5"? No, not on this planet. No.
Oh, I actually believed it for some reason.
You're taller than him.
That's outrageous. Saying he's taller than me is kind of outrageous.
All right, Caesar, how tall are you?
69 inches.
69 inches? All right, so we're going to use his height. 69 inches, and let's do that. He's almost 6 foot. He's getting close. What percent of the heights are less than or equal to that?
Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
So 13 out of 20. What percent is that?
65.
Good. 65%. It's just ratios. Just ratios. And of course, you could use your calculator if you had to. All right, moving on. Complete the table. What we have here is a frequency table. Like you could make a histogram out of this. Looks like a histogram table, right? So the first couple are set for you. Now notice we're adding 2 sections. Relative frequency just means percent. Cumulative, we'll cover that in like a minute. Just hold on. But let's go back and count. How many dots on our dot plot are between 66 and 70? I got 11.
Oh, 11.
Oh, when including?
Uh-huh.
Oh.
God.
Oh. I can believe me, man. I didn't know.
So 11 out of 20 is 0.55. What about between 71 and 75? 3. 3 out of 20. What percent's that? 15. Good. 0.15. And then 76 to 80? 1. 1 out of 20. 0.05. Okay, now, what the heck is cumulative? It's when you start at the top of the table and the percents accumulate because you're adding them all together, all right? So I started with this 5 right here. This is 5%. I'm going to add the 20% to it, and I get 25%. See how it's accumulating down? So then I'm going to add 55%. What comes next? 80%. And then I'm going to add 15%, and I get, very good. And add 5%, I should get 100. Wasn't that great? Now, it should accumulate to 100 because they're accounting for 100% of the data, right? Great, awesome. Now, what you're seeing next is a plot called a cumulative relative frequency plot. It's a mouthful. What's happening is on this y-axis are the percentiles. And then you have your variable of choice on the x-axis, height. All right? So we're going to take that line. Our line is going to ultimately end up at 100% accounted for, right? So we're going to take it into groups. So that first, from 55 to 60, was only 5%, right? So I'm going to draw my line to just 5% and land it at 60. And then 61 to 65, there's 25%. Once I get to the top of that, it should go up to 25%, right? We're just using these cumulative values now. So I'm going to eyeball that. Then 66 to 70 jumps all the way to 80. 71 to 75 goes to 95. And then 76 to 80 takes us all the way to 100%. Not bad, is it? So notice with me, which of the, if we were making a histogram, which of the bars would have been the tallest? The 66 to 70?
Oh, yes.
Because it has 11? So notice on the graph, that's indicated right here. It's the steeper slope. Yes, sir?
How do you know, like, how much to break it up into, like the sections, like 56 to 60?
Oh, it doesn't really matter. The rule of thumb is usually you want to have at least 5 sections. As long as the data breaks up into 5 sections, it doesn't really matter where. Now, if you do it on a calculator, it's going to get really specific, like 2 or 3 decimal points. We don't necessarily work like that. So it doesn't really matter as long as it's clearly indicated.
And it's 5 equal points.
Mm-hmm. Everyone has to have the same width. All right, now, so percentiles. If someone in the class is 66 inches tall, estimate and interpret the percentile they are at using the graph. And we spelled they with an E. There we go. Let's fix that. All right, so if they're 66 inches tall, I'm going to start with the axis with inches on it, which is which one? The x-axis has inches. So estimate where 66 inches falls. And then you're going to draw a line up to the curve and then take a left and estimate what percent that hits. Approximately what percent? 30-ish, maybe? We're approximating. Whatever. 25, really?
28. Such a good number.
We'll go with 28. Yeah. So when you're doing this, you're approximating. So if you say 28, he says 25, it's fine. If you say 28 and he says 15, he's wrong. Just straight up wrong, right? Anywhere in the 30 range, we're good, okay? We're estimating. So how would I interpret? This is going to be a big one. Another interpretation you have to get right when you're wording things, okay? You would say this, approximately, what do we say, 30% of the class is 66 inches or shorter. Okay, we're talking less than or equal to, right? So we're putting that in words, in context. Less than or equal to in height is shorter, height versus taller. Estimate and interpret the 80th percentile. So this is taking us from the percentile axis, which is your y-axis, right? So let's go over here and pick up where it's 80. So 80, start here, come across, come down. We're estimating. You may be closer to 70 than I am. I don't know. Looks like you can draw straighter. Somewhere close to 70? Definitely between 70 and 75? All right. That's the height that falls at that percentile. So to interpret this, we would say 80% of the class is approximately, so notice I'm putting approximately with the estimated value, right? Approximately 70 inches or less in height. Less than or equal to has to be communicated, not just less than. All right, context is always a big part of it. Can we handle that? No higher level math yet, right? It's just literally percents and adding. It's no big deal. Back page, let's summarize. Percentiles is the percent of the values in a distribution that are less than or equal to a given value. Less than or equal to a given value. So when you interpret, you got to communicate less than or equal to whatever the value is. Make sure you never say in a percentile. You're not in a percentile, you're at. It's a location, okay? So it's a location within a distribution. If you line them up, least to greatest, where do you fall? At what percentile? All right. Now, I'm just going to make one up here. There we go. Fun. On your distributions, remember this side is the percentiles. And this side is the value of the variables. So important percentiles. Look, we're connecting back to chapter 1. What does Q1 refer to?
25%.
Yeah, it's the 25th percentile. What would the median be?
50.
The 50th. And Q3? 75th. All right. So here's what's really common. When they give you one of these, they'll say, okay, what's the IQR of this distribution? How do you know? What is IQR? Q3 minus Q1. Can we find Q3? Yes. Can we find Q1? Yes. So Q3 would be like, this is going to always go up to 100%. So 50 be here, 75 is in there, 25%. So whatever these values are is my Q1 and my Q3. Okay? So you have the tools to find it. It's just not going to be given to you really, really clearly. All right, we good? All right, you want to do these together to go faster? Sure, great. Okay, according to a 2019 article at insider.com, the state of Pennsylvania was at the 82nd percentile for pre-K to 12th grade education and at the 0th percentile for higher education. What do these values mean? So we would say how would you say it? 82% of, we're talking about all the states, right? Yeah. Of the states how is that? Have a pre-K to 12th grade rating less than or equal to Pennsylvania. Just going to abbreviate PA. Pre-K to 12th grade rating less than or equal to Pennsylvania. And then how the heck would you do the 20th or the 0th percentile? Yeah. Yeah. 0% of the states have a, what is it, a higher education rating. Less than or equal to Pennsylvania. Less than or equal to, right? All right, so here's that question. Here's the graph that displays the cumulative relative frequency of the cost of in-state public education, college education for each of the 50 states. So tuition's on your x-axis, percentiles on the y. About what percent of states have an in-college public college tuition less than or equal to 8,000? Well, here's 8,000. So I'm just going to read right across. So approximately 60% less than 8,000. Okay. Or equal to, I should say that, huh? What about more than 8,000? How would you find that? Yeah, it's just 100 minus 60, right? So if this piece is less than, that means this piece is greater than, isn't it? So 100 minus 60 would mean that approximately 40% have tuition greater than 8,000. All right, estimate. Yes, sir.
Is there any reason why they went to the 120 percentile? Like, is there any reason?
No, you wouldn't go higher. It's just probably for eyeballs, just be able to read the chart better. Estimate Q1, Q3, and the IQR of the distribution of phone in-state public tuition? What does that mean? I don't think phone is part of this context, is it? No. All right, so let's estimate. What do we think Q1 is? You think it's 7? I think it's just 6. Y'all are overthinking it, bro. Thank you, Jace. Thank you. All right, Q3. I probably would say 10, but you're close enough. You're in the ballpark. Okay, so if that's 10,000, what's the IQR? Good job. Would you have to show your work? Yes, of course. No naked answers.